Hello everyone, you are all welcome to lecture number 1262 and today's lecture is in continuation of the reaction mechanism and how the electron displacement or movement along the single or double bond is playing in the reactivity of the molecule. So in the last lecture I have already discussed about the inductive effect, that was permanent effect, and it depends upon the linkage or bonding of more electronegative atom or group as compared to hydrogen. And today I am going to discuss the other effect that is called electromeric effect. Electromeric effect is on demand of the reacting molecule, means a reagent, and how it is going to attack. For example, if we have carbon-carbon double bond or carbon-oxygen double bond, so in these two conditions, the carbon-carbon double bond is more stable as compared to carbon-carbon oxygen bond, because in carbon-carbon oxygen bond, that is called carbonyl bond, there will be polarization of temporary effect towards oxygen, and once any nucleophile which is rich in electron is attacking, it will be your negative electromeric effect. While if it is carbon-carbon double bond and if it is acidic medium H positive, means that H positive is going to get electron from the carbon center, then it will be electromeric effect. So these conditions I am going to discuss in detail. So here I am going to discuss about the positive electronic effect, and that positive electronic effect we can see in carbon-carbon double bond on the demand in acidic medium, that is called H positive. If I say H positive, means it is without any electron. So where it will be attacking, it will receive the electron from that center. If such condition is there with this effect, where any species attacking species is deficient in electron, it gets the electron from the carbon center, then it is called positive electronic effect. So here, number one, electronic effect involves the complete transfer of electrons to one of the atom of a multiple bond. It can be double bond or triple bond. Here the transfer of electron depends upon the requirement of the attacking reagent, and attacking reagent may be acid. If it is acidic, it will be proton like H positive. Consequently, one end will be positive and the other will be negative charge, and which add the reagent to attack. In this effect, the shift of the electron is shown by curved air. This is the sign of, if anywhere this sign is shown in any reaction, it means there the electromeric effect is taking place in the reaction mixture in the molecule, which is in the form of intermediate. This curved air is the sign of electromeric effect, means it is transfer of electron completely, and it is not permanent effect, rather it is temporary effect, and indicating the direction of the electron shift. It is indicating, curve is indicating that in which direction the electron shift is there. For example, here, so if I am showing in this reaction, it will be like this. This curved arrow means pi electron from the pi bond, it is towards this direction. That is when you are adding acidic reagent. but once you remove the acidic reagent, then it will be reversed again to its original direction. So in the previous lecture, I explained to you about the sigma bonding and sigma electron. Here there is transfer of electron from pi bonding, pi overlapping or pi electron. So now the students should understand what is pi electron. Pi electron means are those electrons which are held up in the overlapping of the orbital in parallel fashion. The overlapping of the orbital in parallel fashion like this, vertical. This overlapping is called pi overlapping. For example, here, let me show you, like here, now I can show you here. For example, if there are two carbon, and if these two orbitals are, these two carbons are there, and they are overlapping in a parallel fashion. It is a parallel fashion, one each other. In this fashion, this overlapping is called pi overlapping of orbital. It is called pi overlapping, and whatever electron is held up here in this overlapping, it is called pi electron. It is called pi electron, and whatever bond is formed by this pi overlapping and where the electrons are held up, such bond is called pi bond. So this is the concept of pi electron and then pi bond and pi overlapping. And here, let me make it very clear to students, in these two type of overlapping or bond formation, one is sigma, where axis, front axis they overlap here. The other one is parallel. So the one which is in the form of front axis overlapping, sigma bond is the strongest bond, very strong bond. While where the two orbitals are overlapping in parallel fashion like this, here the electrons are loosely arranged. It is not a strong bond, so it can be shifted very easily. So this is the concept of your pi electron and pi overlapping and pi bond. So here I have, it is given number 2. The electronic effect is of two types. One is called positive electronic effect, and I have already given you the explanation. Positive electronic effect means where the attacking species is receiving the electron from the center of the molecule. That is called positive electromeric effect. And other is called negative electromeric effect. And if the electrons of the pi bond are transferred to that atom of the double bond to which reagent gets finally attached, then the effect is called positive electromeric effect. For example, A and B, two examples I have given. In A case, CH2. So this proton is attacking to this carbon center, means it is going to get electron from here, and this carbon is getting electron from here. So now this carbon will be developing positive center because it has donated the electron to this carbon to coming acidic species, and this effect is called positive electromeric effect. In the reaction B, CH3CH2, again the proton is attacking, means proton is not having electron. It is going to get electron from this carbon, and then this carbon, it will be shifted to here by this curve arrow, you can see, and then it will become CH3CH. CH3 means here in the center the positive charge will be located. So in reaction intermediate, the second condition is where the attacking reagent is rich in electron, or we can say it is nucleophile, like Cn minus, OH minus, means they have extra electron. They can donate, they can supply the electron to the carbon center. Such effect is called negative electromeric effect, and it is given by minus. So here, the negative electronic effect, in this effect, the electron of the pi bond or double bond are attacked by the reagent rich in electron, and they are nucleophile, and by donating the electron, then this effect is called negative electronic effect. For example, is carbonyl group. So in carbonyl group, when Cn group is a nucleophile carrying negative charge, means it is rich in electron. Once it is attacking to this carbon, this pi electron will be shifted to oxygen. So it will be linked to this carbon, and some electron will be transferred here to oxygen by this carbon. Here it is clear, and then you will get CH2Cn, CO minus, and this effect is called negative electromeric effect. So with this I will stop. Thank you very much for watching the lecture.